Hey, it's Piotr Gankiewicz here, and welcome to the second part of the .NET Core deployment series. Let's start with a quick reminder about what we did in the previous part. So, we started actually with having our .NET Core app. We used the Fibon application that is available here in the GitHub, and we decided to actually use the Docker Compose, and later on publish our app to the Ubuntu virtual machine using the Docker and the Nginx server. So we went through all these steps, starting with the Dockerization, then with the automation using the Travis CI and the Bitbucket as our build servers, and finally the deployment part, in which we used our virtual machine running in the cloud with the Ubuntu server, and eventually we added here Nginx running as the HTTP server. In this part, we'll focus on the orchestration. And in order to achieve the orchestration, we'll make use of the Rancher. So what is the Rancher? If you go to the rancher.com, you will see there is this very great project, and it's for free and it's open source. So basically, you can just click here on the download Rancher and start using it immediately. Rancher is as you can see here, is a container management platform. Actually, it provides you these orchestration services that are required to build scalable apps that are being monitored by some external tool. In this scenario, the Rancher, that it also takes care of adding cost, replication, adding more instances, load balancing, security, and so on. So there are features, tools like Docker Swarm, Kubernetes, Apache Mesos, and so on. And this is where the Rancher comes in play, because it's like on top of all these things. So if you go to this download Rancher, you'll see that there are two options. The first one is to run the latest version 1.6, the latest stable version. And I've been using this one for my applications. But there is a new Rancher 2.0. It's in the preview mode for now. But from what you can see in the roadmap, the Rancher guys say that it should be available like the stable release probably by the end of the year. So we'll just see how we can actually use this 2.0 version, and later on I will also show you how to work with the 1.6. So we have the following structure here. We have 3 virtual machines. The first one will be where the Rancher host resides, so this one. The second one we'll use for the load balancing purposes, and the last one we'll use to actually deploy our services. Okay, so what we want to do now is to actually log into our virtual machines. So I will just use SSH. And here, what I did, I only ran this apt update command. So I basically run this one, and later on I also ran install docker io. That's all I did. And I did the same for the 3 virtual machines. So here, in order to start the Rancher host, we need to just copy this command. So I will just copy this one, paste it here, and we'll run our Rancher. I already downloaded the Rancher image here, so we won't waste our time just watching when it's fetching the image from the Docker Hub, but it will take maybe a minute for you when you have a fresh environment. And now when you type docker ps, we'll see that it's starting. Depending on the power of your virtual machine, it may take up to like a few seconds or a minute or two. So we should be able to actually access our Rancher here at this port 8080. So I should be able to copy this IP address, paste it into my browser, and just type 8080 and open the Rancher. We are using version 2.0, so there is a difference not only at the user interface level, but also on the internals. So by default, the Rancher from 2.0 runs on the Kubernetes, totally using the Kubernetes from Google. In Rancher 1.6, you are able to use other orchestration services such as Kettle that was built by the Rancher team, or the Docker Swarm, or Apache, or also the Kubernetes. And 2.0 is fully devoted to Kubernetes from as far as I know. Okay, so once you start the Rancher, there are multiple things here. So what you would do at first, you would just go to this admin and the access control, and here you would set up your password. So you wouldn't probably for someone else to access your Rancher, but like I said, this is a preview version, so there are still some features missing, but the most important ones are here. So you would just go here, click the local, and provide your username and password, or maybe the GitHub authentication or whatever is the best for you. So that's the first thing that you would do. Now let's get back here into our containers, or actually here. As you can see, we can go to this manage clusters, and there are two things, like there's a cluster and there is an environment. So from what you can read here, we can have like a single cluster, let's say the production. And for the production, we can have one or more environments. So for each cluster, you can have one or more environments, right? So environment is tied to a single cluster, but you can imagine you have a cluster, let's say the testing cluster, and under the testing cluster, you have different environments for the different testing purposes. But we'll keep it simple here, and we'll just create a new cluster. And let's call our cluster just the production cluster, or just production. And we will just call create. And once we have a cluster, we can just click on this add environment. And let's just say we want to have here under our production cluster, the production environment. So the cluster and the environment will be called production. So we have our cluster, we have our production. Now it's high time to add some hosts. And the hosts are virtual machines. So we go to the hosts. And here, as you can see, we can already choose the existing Kubernetes infrastructure, or we can add our own host. So I click here, and at the first time, I just want to say that this is the base URL of my Rancher API. But be aware that you can also have this Rancher running under this high availability. So you can have multiple instances of Rancher running just in case if one of them went down. So let's click save. And here we have multiple integrations. So for example, you could use already existing Amazon or Azure or the DigitalOcean. As you can see, there is a pretty good interface. You would just paste your API access token here, and you would get to this another screen where you'll be able to actually select all of the virtual machines over different sizes in different regions, like you would do in a DigitalOcean or in Azure or Amazon. Okay. But in that scenario, we will say want to have our custom virtual machines that can run anywhere. So I have these two virtual machines here prepared. So I will just copy the IP address and open the new terminal session. I already have installed Docker here, and I just need to copy this command and paste it to my virtual machine like this, and click enter. And this one will fetch this Rancher agent image and register my virtual machine. So let's wait for it. And in the meantime, I'll also connect to my second virtual machine. So SSH roots. Okay, so this one already completed. So as you can see, we have our new host available here. So I'll just click close and register my second host. So again, I'll just copy this one, paste it here, and I'll wait a second until it finishes downloading the image and registering my host. So let's just give it a minute, and we'll have the two hosts ready for our development purposes. And the idea is that we want to have this main host running as the Rancher host. We don't want to put any services here, but of course you could do it if you want to. Then I want to have a separate host where only my load balancer runs. And then I want to have another host where I will keep all of my services. But as you can imagine, I could also have it, for example, like this. Like another host here, and as many hosts as I need, and I could spread all of these services across multiple hosts, having them many different instances running at the same time, and so on. So I could scale it horizontally pretty much infinitely. Okay, I have my second host here. So Rancher Dev1 and Rancher Dev2. And before we do anything else, let's just go into our host settings. I'll just click edit. And what I want to do, I want to have this one as a load balancer. So I will just add here a new label. The label can have any name. So let's say I will call it environment label, and let's name it load balancer like this. The first label. And for the second host, I'll add also a label, but this one I will just call environment and maybe services. And the reason I'm doing this is because I want to say my load balancer explicitly to run only on this host and my services to run only on this host. For example, I wouldn't like to mix my services with my load balancer host, even though for our system it doesn't really matter. Let's say I like to keep it clean and really separate, so I don't want to interfere. Okay, so I'll just have these two different labels here. All right, so now it's time to actually add our containers, right? So let's get into our containers. We have a few options here. So at first, let's start with our Fibon. In order to do it, you could basically click here on Add Container, and you could provide here any container you want from a public Docker Hub registry. You could also go here to the registries, and you could add your own registry here. For example, let's say you're using the Azure registry with private images or the Docker Hub with private images. You would just provide here your username and password, and you would be able to fetch your private images from your registry. So that's how you can actually register your registry here. But let's get back into our containers, and here I will just call this import from YAML. And let's say I want to call my stack Fibon, okay? And I can call this add file. And here I could just open my file from the disk, or I could just copy the contents of the file. So I'll make use of my Docker Compose YAML here, and I can get rid of this one. So let's just copy the contents and paste it here like this. So we have our API, the service, and RabbitMQ, and let's just click create. It will take a minute to actually create all of our services, but once we get back to our host, we'll see that our services, they are being pulled from the Docker Hub and they are about to start. We can also switch the view here. So for example, we can see it like this, or even better like this. So we see that there is the first virtual machine, the second one, and there is our service, there is our Rabbit, and there is our API. And like I said, I would like to have all of these services running only at this Ranger Dev2, which has this environment services label. What I can do is to actually get back to my containers. And here, let's say at my Fibon API, I could just click edit. And under this host scheduling, I could say, I want to add a scheduling rule. And here you can have different conditions, but I would just say, I want to have this key environment, and it has to be equal to services. And I click upgrade. Then I go to my Fibon service, and I do the same here. So again, environment services, and finally to my RabbitMQ. So the host scheduling, again, scheduling rule, and services. As you can see, our services are being updated now, and they are being transferred to this machine here. As you can see, we have our Rabbit API and service. This one will be gone in a minute. So we have the clean virtual machine that will serve only as a load balancer for us. All right. And okay, let's now add a load balancer here. So I will just click here, Add Balancers, and I will click Add Balancer. And here I'm actually able to specify all of the load balancer stuff. And by default, it uses the HA proxy load balancer, high availability proxy load balancer, which is a very powerful load balancing system. So it's being used by the Rancher by default. So let's just say I'll call the service load balancer, and I want to add it to my Fibon stack here. And I also want to have this scheduling rule, and I will just say environment equals load balancer. And here is where all of the load balancing magic happens. Okay, so I can say that I want to expose on port number 80 with a public access, and here I have my rule, like what do I want to really expose. So I just click here Add Service, and I choose Fibon API, and here I'm passing my internal port. So I know that my Fibon API runs under the 5000. So I just click like this, and that's it. And let's say I would also like to expose my Fibon service. So I'll just say port 8080, add a service, and I know that my service runs under 5050. Okay, and basically what you would do in a typical scenario, you would open your resources tab, and under your resources tab, I will show you this in my other application later on. But at first you would go to the certificates and you would add here like an SSL certificate by pasting your private and public keys here. You would save it. And then here you could basically switch between different protocols. Like you could have the port 80 exposed for HTTP or 443 for HTTPS. And you could just here below select the proper SSL certificate. That's how you can actually easily add your certificates to the load balancer. But we don't have a certificate yet, and we don't have a domain. The same applies to the domain. For example, here I could just type api.fibon.com, given that I would own such a domain. And for example, here below, I could just say the service.fibon.com. And based on this domain request, I would actually access either the service or the API, and they would both be exposing the default port 80, okay, instead of some random ports. But we don't have our custom domain, we don't have a certificate, so we'll just keep it simple. Okay, so we have our API and our services exposed via our load balancer, and let's just click create. It will create our load balancer. And the last thing I want to do is to actually restart my API and service, because I want to make sure that actually our API and service connects to our RabbitMQ. Because as you remember, previously we had to run this using our start dependencies command that would run the RabbitMQ first and then our API and service. So we would be sure that our service bus runs before our API tries to connect, okay? And here I can do many cool things. Let's say I want to see what's going on with my API. So I can, for example, go into my API and I could just click view logs. And here I can see, here are my logs, all right? Or I can just click execute shell and I'm within my container. I can do some things there. Here above, I can see like what's the resources being used, like memory, CPU usage, some network, and hard drive usage. So we have access to such monitoring components here as well. Okay, so what we should be able to achieve now is to basically open our load balancer. Let's get back to it. So our balancers, we have our host here. Let's take a look. So we have our load balancer running here, so we should be able to copy it and access our, as you can see, I copied my load balancer endpoint IP address and I open it, and here's my Fibon API. And if I go to 8080, my load balancer will redirect the move to the Fibon service. So what you would do, let's say you have a domain name and you would point your domain using this redirect, right, to the IP of your load balancer, and then load balancer would just redirect the movement to the particular services running within your containers. And finally, or not finally, what we can also do is to just, by clicking here and edit, we could just remove this port mapping so that our API and our service wouldn't be longer exposed to the external world. So by doing this, we can make sure that our API and our other services are only available through the load balancer, that they do not expose any public ports. So they are basically private by doing this, okay? So if we refresh our service here, it will be accessible again, but it's only thanks to the load balancer. If we wouldn't put it into our load balancer, we wouldn't be able to access it. So this is also pretty important. And yeah, everything seems to be up and running here, which is cool. And what we can do with our services here, let's see. We have some other options like, of course, restart, stop, delete, and so on, a rollback if you want to switch to the previous version. We can also scale our services easily. Let's see how we can do it in the Rancher 2.0. So yeah, you go to the service definition and you can just click scale. And if I click scale, it will actually create another instance of my container here somewhere, right? It will just scale my service. So as you can see right now, we have 4 containers here under the dev. And let's see how our OS looks like. Yeah, we have Fibon API instance 1 and Fibon API instance 2. And as you can imagine, you can just add more hosts, for example, using some custom labels, whether you like them or not, and just click scale. And you would have this horizontal scalability spread through all over the containers running, through all over the virtual machines running all over the world, right? It's that easy. And the Rancher using the Kubernetes system below under the hood will take care of managing all of your movement, all of these deployment issues, and so on. And this is actually how you can make use of the Rancher in order to just deploy your applications, whether these are monolithic applications, web applications, or whether these are really distributed, scalable systems that have to be managed, have to be orchestrated, and really have to be reliable and working all the time. This is where Rancher comes in really handy. And there are many different things you can do with Rancher, and I just shown you like the most basic stuff, like the most useful stuff, so you can get started with using Rancher on your own and playing with it. And let me show you one more thing, which is not available here. But let's imagine we have our build server up in place, up and running here, for example, using the Travis CI. So what happens now if I push the commit to my repository at the GitHub? It will then start my build services. It will build, test, run the app. It will push the Docker image to my Docker Hub. But I'm still missing this part where I could just deploy it automatically, right? So I'm missing this part where I would just go, for example, here to the edit, and I will call this upgrade button that would fetch the latest version of my image from the Docker Hub or any other registry and upgrade it, right? So how you can do it? Well, basically you would go to this admin section, and the resources, and to the webhooks, but it's not available in this preview yet. So I will show you how it works on the different system using the Rancher 1.6, this version. So let me show you how we actually have it up and running for our collectively platform. So there is my Rancher using the previous stable version, right? And as you can see, I have different types of services here. For example, I have the load balancer as well. And under my load balancer, I have like subdomain specified with the ports that I'm exposing, both for the SSL, like the HTTPS and HTTP, using the different APIs running under different ports internally. And I here have like the SSL certificate added. I also have the sticky session, for example, required by the WebSockets. And I also have like the proxy configuration, which redirects all of the movement from the public port 80 to 443, right? So these are all of these things that you can do with the Rancher and the built-in load balancer, okay? So what I have here are these webhooks, okay? And let's say I want to be able to automatically upgrade my service, all right, into the newer version whenever there is a build completed and whenever there is an image pushed. So what I would do, I would just click on this add receiver like this, and I would say, let's say scale API or update API, okay? And I would just say, I want to upgrade the service. And here I would have to provide my image tag because I have two environments, like the production and the dev environment. I would just say latest. And here I would also say, I want to scale only the API. So I would just say service type, for example, the API, right? Or the different name that my image has. So where does it come from? If I take a look here, you will see that, for example, under my API, I also have I have my image name, and I also have the labels defined only for this API specifically, where I'm saying I have this custom label called service type, for example, the API. And by doing this, I'm telling my webhook only to update the API, no other images. And I would just click create here, right? And I would get a new webhook that would show up here. And then what I do with this webhook, I just copy my trigger URL, copy to my clipboard, and then I go, for example, to my Docker Hub. Let's say I have a webhook for my Fibon API that will trigger deploying the new version of my Fibon API here, right? So I would go to this webhook section. I would click here on adding webhook, just provide some arbitrary name and my URL. So as you can see, I have my old webhook that doesn't work anymore, but it looks like this. So it points to my rancher, the API, and some unique key. And this key will actually trigger the existing webhook, let's say this one, and this one will take care of scaling or upgrading or doing whatever you wish with your particular service. So this is how you can actually have a fully automated deployment using the repository, the build service, and the rancher, which will actually deploy the image. Another cool thing is that whenever you upgrade your image, which means that you deploy in a version like here, let's say I have 2 images here, and right now it will create additional containers. So there will be like 4 of them, and you are able to either accept the upgrade or deny it, roll back. So you can think of this zero downtime deployment, right? When there is really like, so the deployment is all about adding new containers, and you just decide if you want to redirect the movement to the new services or not, right? This is how it usually goes. So you can really automate your deployment using the webhooks that are available thanks to the rancher. And that's really all I wanted to show you about the rancher, how cool that project is. And I really encourage you to give it a try. So let's do a quick summary of what we achieved today. So we talked about rancher, how it can manage the services and provide all of these cool features when it comes to, for example, load balancing, monitoring, deploying, adding certificates, custom registries, and so on. So there are also another extensions available that I won't talk about in this video, like how to do logging with Serlog and the Elasticsearch stack. But these ones are actually available here in our Visual Studio Code. So if you would open this Docker Compose -lkx, you have a different Docker Compose that also uses the Elasticsearch. And here under the API, within the app settings, I added this section for the Serlog where you could provide your URL, the username, and a password, and it will run the Elasticsearch. And also here under the Startup CS, I added this Serlog settings using the Elasticsearch, so feel free to play with the Elasticsearch as it's a really great tool for logging, for visualizing the data, and so on. Okay, so let's see what we did. At first, we had our HTTP API and a service, then we added our repository, then we added our build services, then we added our Docker container registry, then we added our virtual machine to which we deployed our services using the Docker and the engines. Then we added rancher that took care of our orchestration. So we had like host 1 for the load balancer, host 2 for the services, but you can have as many hosts as you wish. And we added our load balancer, so it will redirect all of the movement to the proper services, also using the certificates and custom subdomains if you provided them. And yeah, and finally we have our user who just uses our websites or APIs or anything else. He just talks to the load balancer through through our domain, which points to our load balancer IP, and our rancher takes care of the rest. And we could also add Elasticsearch or any other extensions that are needed by your services. So in order to sum up, there are a few important things. As you can see, .NET Core lets you do a lot, but like I said, you could use any technology. I just like .NET Core, and I've been using it since early beta or alpha version. I don't remember, but this is just a tool. It's just a technology, just a language and a framework, right? So you could use any other language in order to achieve all of these things we did within these 2 episodes. You should also realize by now that containers are not just a hype. That continuous integration deployment can be even a few lines of code. some basic bash scripts or whatever, that Linux doesn't really bite and it's not as scary as it may seem, that the orchestration doesn't really have to be that complicated, and neither the centralized data logging, but this is the sample of the Elasticsearch that I didn't show in this video. And finally, and that is just a tip of an iceberg. And I hope that you enjoyed this video and that you learned something useful. If you have any questions, feel free to add them as a comments or just email me. You can find my blog, my website, and all the contact info here under my website, and also under this About Me section, or the contact actually. So feel free to contact me, to reach me, to post any questions, and see you next time.